and y-axis y dash is equal to y plus ty. We adding this translation distance vector from the previous point. We got a new position x dash and y dash. Okay, that is translation. Okay, and then next that is one more point is we notice that translation is a rich body transformation, which means that is without a deformation. The object which moves from one position to another object. Okay. Okay. The next one has translation. So this is an example for translation. Translation vector tx and ty. We initialize the translation vector as a initial coordinate position as 2, 2. We given the translation vector tx is equal to 1 and then ty is equal to 1. So we substitute by using this formula x dash is equal to x plus tx, that is x value is 2 plus translation vector tx is plus 1 is equal to 3. Okay, as well as the same method for y dash is equal to y plus ty, that is 2 plus 1 is equal to 3. So we got a new position adding one position, that is x dash and y dash has to come from old coordinate position 2, 2 to new coordinate position 3, 3. Okay, are you understand here what does mean by translation techniques? So before that we want summarize this translation techniques. What does mean by transformation? This transformation is nothing but a rearranging the orientations and size of the object. This orientation is nothing but a positioning, and then size means that is object which relates its size. Okay, the first one translation, rotation, scaling. The translation and rotation is applied for orientation. The last one scaling is applied for resizing the object. Okay, for this translation we given a translation distance vectors as well as old coordinate position. For obtaining or for calculating the new coordinate position, we use a old coordinate position plus translation distance. Okay, then next we move to the rotation. For rotating the object, that is repositioning the object in circular motion, that is circular path. Okay, so before the translation is applied for only single line, here rotation is applied for circulating the object. Okay, that is repositioning by using circular movement. For that, we repositioning the object, we use a rotation angle from the new coordinate position, that is x r comma y r. For example, the old one we have a 30 degree means the new coordinate position we have a 60 degree. So from 30 to we translating the 30 degree position to 60 degree, that is rotation. Okay, the last one is a scaling. The scaling is applied for repositioning the object. For repositioning the object by using scaling distance. Okay, and this translation we using translation distance, and the scaling we applying the scaling factor or the scaling distance. Okay, the formula for calculating the new position for each and every object is x dash is equal to x into y dash is equal to y into sy. Xx and xy is nothing but a scaling factor. Okay, so we see the example. We have one object in this square shape. So the coordinate position value is 1, 1, 2, 1, 1, 2, 2, 2. And then we have some scaling factor values as Sx is equal to 2, Sy is equal to 1. We substitute these values that is scaling values into the old coordinate position. We got a new position as for 1 comma 1 we get 2 comma 1, for 2 comma 1 we get 4 comma 1, and then 1 comma 2 we get 2 comma 2, and then 2 comma 2 we got 4 comma 2. Okay, for the squaring object we translation the size into the rectangle object. Okay, this is a scaling techniques. Or you understand this three basic transformation? Okay, thank you.